Hi, I'm Jeff Rosenfeld. I'm editor of the Bulletin of the American Meteorological Society, and I'm here at the AMS annual meeting in Phoenix with a special guest. This is Bob Atlas. He is the director of NOAA's Atlantic, Oceanographic, and Meteorological Laboratory, which means research and a lot of good things that come out of research too, all at once. Bob, when did you get into meteorology and how did that all happen? Or was it even meteorology at first?
It was meteorology from the beginning. I started at age 12, and from the time I was 13 to 18, I worked as an apprentice forecaster for the U.S. Weather Bureau, forerunner of the National Weather Service. After college, I was a forecaster in the Air Force, and then after graduate school, I was a research scientist for NASA for 32 years, and for the last 10 years or so, I've been with NOAA.
Wow. Now, what was it that got you interested, do you think, at age 12?
I was always excited by the weather. I grew up in New York. We had varied weather. It was always interesting. Even fog interested me, and I read and learned as much as I could, and I was very fortunate to get this apprenticeship so that I learned a huge amount about forecasting before I even got to college.
Now you ended up, or at least started out, spent a lot of your time at NASA. What were you doing there?
For NASA, my main job was making satellite data useful. Satellites were a little bit ahead of the data assimilation and the NWP applications. I worked with some great researchers who were there as well, and we developed improved data assimilation methodology. We improved the way the satellite data was utilized. We made quantitative satellite data useful for the first time. That was with satellite temperature soundings. I pioneered the application of satellite surface winds to numerical weather prediction, and for the last decade or more, I've been among many who have advocated Doppler LiDAR wind as a way of getting wind profiles around the world. We routinely measure the mass field. We don't yet measure the wind field adequately globally.
So you think about observations a lot, obviously. Yes. And in your job at AOML, what kind of observations are most critical, and where do you see sort of improvements coming in that area?
Okay, well, there are, AOML being an oceanographic and meteorological laboratory deals with a very wide variety of observations. We have seagoing oceanographers who deploy many in situ observations in the oceans. We also make use of satellite observations of the oceans. For weather, we focus our work on the hurricanes. We have NOAA's Hurricane Research Division at AOML, and there we participate in the development of new space-based observing systems, new in situ observing systems, and in particular we make use of NOAA's aircraft. We fly new observing systems into hurricanes, and generally our scientists pioneer the applications to hurricane prediction, and this has improved forecasting over the years.
So when your research scientists are saying, I need some help getting observations in a certain area, or there's something that we haven't had a chance to observe yet, what are the things that nag at you the most? Like, I wish we could observe something.
Well, before that particular question, there's a more important one, which is, when we want to get an observing system for atmospheric sciences or for oceanography, is it the right one that we're trying to get? How useful will a particular observing system be? And to that end, we perform something called OSSEs, Observing System Simulation Experiments. The OSSIs have been around as long as numerical weather prediction. In the 1980s, we improved the way OSSIs were done to make them more realistic, more credible, and we've used OSSIs to evaluate the value of observing systems while they're in the conceptual stage, and then later to feed back information to engineers to improve their design and to then evaluate, will it be worth the expenditure? We want to be sure that everything we propose is a good value for the taxpayer.
Okay. Now, what makes OSSIs today, say, more sophisticated than they might have been in the 80s?
Well, in the 80s, they became more sophisticated in that we checked them against real observing systems. So in an OSSI, you simulate all of the existing observing systems, and you simulate the new ones you want to evaluate that don't exist yet. And what we do is we perform impact studies, data denial studies, for the observing systems we already have in the OSSI mode and in the real world. And for the OSSI to be credible, you need to get similar impacts in the OSSI system as you're getting in the real world. So the value of radiosons or satellite radiances or satellite motion winds in the OSSI system has to be similar to what you're getting in the real world. Then if you add a new observing system and evaluate its impact, the results you get will be credible.
So take, for instance, not such a big system, but bigger than anything I want to handle today, a hurricane, let's say. Is it possible to do an OSSI and get really credible results like you're talking about at this point?
So we, at AOML, we've been developing OSSIs for hurricanes, and we have many partners throughout the atmospheric science community, in both the private industry, academia, and other agencies. There are many talks, I think at least a dozen talks at this conference that will deal with OSSIs, and most or many of them will deal with OSSIs for hurricanes, including my own talk tomorrow.
All right.
And for this, we're looking at how do we utilize our existing observing systems better for hurricane prediction, such as unmanned aerial systems and the hurricane reconnaissance planes. And then what will new observing systems do, add to the ability to predict hurricanes accurately. But even beyond this, OSSIs can be used to address predictability problems. So one of the common predictability problems with hurricanes is that if you initialize a regional model with an intense hurricane, it tends to spin down, to weaken within the first 6 hours and give you large errors. In the OSSI system, where you know the truth perfectly, we've evaluated that particular problem and have found that it's solvable. And where we're going with this is to determine what exactly do we need in observations to eliminate this, and how can we then deploy unmanned aerial systems and the hurricane reconnaissance flights in conjunction with satellite data to eliminate this and other problems and thus improve forecast accuracy.
So
and this will be a part of my talk tomorrow.
Oh, okay. Well, I will hope to attend. Sounds like a good strategy for making you both more nimble and more smart, so to speak, I guess, for operations. So I hope this meeting goes well for you, and we'll look forward to hearing more about the OSSIs and other projects at AOML during the meeting. Thank you very much, Bob.